word on the street is you need to learn about logs. Well, hey, let me tell you, you came to the right place. And the music stopped. How about that? I guess it's time for me to start teaching. Hope your day's been going well. What's your bright spot? My bright spot's the new year. It's January 6th, so if you're still feeling good about the new year. All right. Well, let's get started. Let's look up here. Log base 2 of 8. You're probably sitting there to yourself saying, Mr. Miller, what the hell is that? If you're saying, what the hell is that? You in the right spot, because this is the ground floor, ladies and gentlemen. So I think the first step to understanding logs, number one, is to realize that it's always a timesy thing. Like when we're talking logs, we're talking about a world where we are multiplying people, okay? So keep that in your head the whole time. You see that word log, you should just raise your hand and say, we multiplying here, right? So this is not a linear thing. All right, it's the best way though. I think maybe I already said that, but the best way is to draw a picture. So let's draw a picture of what this wonderful log is gonna do for us, okay? So watch this. Okay, so when we say log base 2, that base, that's like the size of the count. Like you're gonna, and the count is timesy, right? So you're gonna keep multiplying by that number for all eternity, right? So right now with this problem, we are living in a world of times 2. So let me put times 2 onto my counting line. So what the log is going to do for us, and I even got a little prop here for you today. I know, it's pretty good, right? Is this. It's going to tell us where is 8. Like if we keep multiplying by -2, how many counts is it going to take to get us to 8? That's fundamentally what logs do for us. They say, I know how big my multiplication is. I know where I'm going. I just don't know how long it's going to take to get there. So here, it could be here, here, here. So you can go to your calculator or learn to evaluate it. In this case, we'll just kind of evaluate it. So let's go 1 times 2 is 2, right? Times 2 is 4. Times 2, maybe I'll switch to purple here, is 8. So it takes 3 counts of times 2 to get to 8. And so log base 2 of 8 is 3. Let me write a quick description. Okay, so when you got a log equation or expression, you have the log, which is telling you, okay, we're multiplying, right? The base is the size of the count, but it's a timesy count. So you're going to be counting by multiplying every time. The big number here, this is going to be what you're counting to. Okay, so log base 2 of 8 is going to be equal to what it equals is going to be the number of counts. So how many counts does it take to get to 8 if you're multiplying by 2 every time? Let's get another one. All right, so we have log base 5 of 625 is equal to what? Hit pause and try to figure it out. Pause, unpause. Well, let's first draw the picture, right? All right, so what we're doing here, I think I have a 625 prop. I do. Is we're gonna ask ourselves if we're gonna multiply by 5 over and over again, right? So we're counting by times 5, and we start at 1. When are we going to get to 625? Like, how long is it going to take to get to 625? So let's go back up here and figure it out by looking at our number line. So we're going to have 1 times 5 is 5, times 5 is 125, times 5 is times 5 is 25, times 5 is 125, and times 5, I think we've landed on it, is 625. All right, so log base 5 of 625 is 4. Because, now, it's going to be helpful to realize the connection between using logs and then using exponent notation. So if we use exponent notation, what we're learning here is that 5 raised to the 4th power is equal to 625. I keep picking up the wrong purple marker. I got one good purple marker. I got one that's not so good. And I keep picking up the one that's not so good. I'm sorry. I'm sorry. All right. You feeling good about logs? Well, let's try another one. What the hell? You only live once. Okay, why don't you give this one a shot? Log base 6 of 216. What does that equal? So, be thinking to yourself, 6 times 6 times 6, right? Like how many, you know what actually might be worth doing? It's just writing this equation in exponent form like right now. So if I was to just do this right now, what I would say is 6 raised to the I don't know what it is, right? I'm not sure, is equal to, is this the good purple marker? Let's see, 216. So what is that exponent? How many counts of times 6 is it gonna take? Well, let me draw it out. All right, well, let's look at this. You still with me? Come on, stay with me. Stay with me now, all right? Oh, gosh. Oh, I need some water. I know I grabbed a coffee cup when I said I needed water. But it's kind of the same thing, right? It's mostly water. Okay, so where is 216, right? When are we going to get to 216 when we multiply by 6? There you go. Put it into your calculator or just figure it out. So we got 6 times 6 is 36 times 6 is 216. So I'll put that blue, no purple. Switch that to blue because that's the solution. It's 3 counts, right? So log base 6 of 216 is equal to 3 because 6 to the 3rd is equal to 216. Ta-da! Mr. Miller, I think I got this. Oh, well, I'm really happy about that. Can I give you another challenge, though? If you think you got this, let me bring you one step further, all right? Come with me. Ta-da! All right. And you're already looking at that like, oh, damn you, Mr. Miller, damn you. Can't believe you brought in a fraction. It's okay. You're going to like this, actually. So log base 2 is 1/4. So if you're multiplying by 2, when are you going to get to 1/4? Well, let's draw it first. Okay, so right now, one of the things we see is that the numbers are all bigger than 1. And that's a fraction. It's 1/4. It's less than 1. So we're never getting there this direction. But you don't have to start. Like, you don't have to count one direction. You can count backwards, right? Right? When you learned to count, you were saying, okay, 3, 4, 5. But you could also go 5, 4, 3. And you could do the same thing when you're counting in a timesy sort of way. So what we can do is go -1, -2, -3, where negative is actually just a count in the other direction. So we're still counting by times 2. Like, it's still times 2 times times 2 times times 2 forever, right? That's the point of log base 2. Now, where the hell's the 1/4? Well, it's not over here, that's for sure. So it's got to be this direction here. And remember, when you multiply, you can't get to 0. You ain't never getting to 0 if you multiply by 2. I tell you that much. So what's happening here is you can kind of see is that now we're generating fractions. You see that? That 1/2 times 2 gets you to 1. And so this is actually going to be 1/4. And now, so the -2, I'm going to switch to blue, and we get -2. Because fundamentally, because 2 to the -2 is equal to 1/4. Because you remember that exponent rule, right? That 2 to the -2 is 1/2 to the +2. There you go. All right, well, let's do a little mic drop. That's it for this video. I hope I found you in a good place. I hope you felt good about this lesson. You're a wonderful person. And remember, angels fly because they take themselves lightly.